Okay, welcome to Chemistry A, Unit 4, Day 3 and 4, Video Guide, Part 2. Today we're going to talk about some more calculations that we need to do here in the stoichiometry part of this unit. And today we're going to start off with talking about calculating the number of moles to the mass, calculating moles to mass. Okay, if you're asked to calculate moles, in other words, you're given the amount of moles and you're trying to calculate the mass, we want you to use the following. Take the number of moles and multiply it by the mass in grams. Now, this will use what we used at the tail end of video guide or note guides day 3, day 4, part 2. That adding up the molar mass of H2 and O2 like we did, that's part 1 of what we need to do for calculating moles to mass. So we are on page 298, the sample problem 10.5. So let's go ahead and get started on that. The aluminum satellite dishes in figure 10.8 are resistant to corrosion because the aluminum reacts with oxygen in the air to form a coating of aluminum oxide, Al2O3. This tough resistant coating prevents any further corrosion. What is the mass of 9.45 moles of aluminum oxide? So, as always, we list what we know. Number of moles is equal to 9.45 moles of Al2O3. What we don't know is mass. Okay? What we have to do first is to calculate the molar mass of 1 mole of Al2O3. And how we do that is just like we do for what we did at the tail end of the last note guide. So step 1, molar mass of Al2O3. Okay, and remember how to do that? We have aluminum is its mass times 2 atoms, and we have oxygen, which is 16 times 3 atoms, which is 48. Get my handy dandy periodic table here and look up aluminum real quick, and we're going to call that roughly 27. So 27 times 2 is 54. 54 plus 48 is approximately 102. All right. So 1 mole of aluminum oxide is 102 grams. Now simply multiply 9.45 times 102, and it will give us the amount of moles, 964 grams of Al2O3. So 9.45 moles of Al2O3 will have a mass of 964 grams, and that is how you convert moles to mass. So now let's flip-flop it and figure out how we calculate the mass to moles. In other words, I've given you how much the mass is, how many moles are there. What is the opposite of multiplication? It's division. So be ready for that. So we're going to use this conversion factor. The mass in grams multiplied 1 mole over the mass in grams. Now watch what happens here. These are not the same. These are not the same. Not the same. All right, let's watch what happens. Oops, excuse me. All right, so let's take a look at 10.6, page 299. When iron is exposed to air, it corrodes to form red-brown rust. Rust is iron 3 oxide, Fe2O3. How many moles of iron 3 oxide are contained and 92.2 grams of pure Fe2O3. So what do we know? We know mass of the compound, of the overall compound, is 92.2 grams. This is the number that will go there. This mass, we have to figure out what 1 mole of Fe2O3 is. So we have to calculate, so what we don't know is moles. So we have to calculate 1 mole of this, and that's that Fe2O3. 1 mole. Okay? And when you do that, Fe, there are 2 atoms. Oxygen, there are 3 atoms. And we know that oxygen is 16 times 3 equals 48. We get our handy dandy periodic table out, and we look at the molar mass of 1 atom of iron is about 56. So it's 56 times 2, which is 112. Okay, 112. 112 plus 48 gives us approximately 160. Now my number is a little different than the book because they didn't round. I rounded. It's not that big a deal. So this number here, 160 grams, goes right there. So now we're ready to use our conversion factor. It's 92.2 times 1 over 160. This is division. Take this number and divide it by that number. Take that number and divide it by that number. And when you do that, you get a number that is approximate to 0.578. Now, if you're using your calculator, you're going to get a different number because of the rounding. All right? And that is how you calculate mass to moles. Okay, so at this point, we're going to start to talk about percent composition and what that means. The percent composition is the relative amounts of the elements in a compound. Now remember, 100% is the full, it's the max. You can only have 100% of something. If you have a piece of pizza, that is 1 slice of the piece of pizza. The entire pizza is 100%. If you take a quarter of that pizza, then you have taken 25% of the pizza. All right? So keep in mind we're talking about percentages, and that's a whole. 100% equals a whole. All right? Now, if we're calculating the percent composition for mass, so you are given a number and says the mass of this entire compound is X. What is the percent of each part that makes up that whole 100%? And when we do that, we will use the following conversion. We take the mass of the element and we divide it by the mass of the compound. And we multiply that by 100, and of course that gives us our percentage. So, the mass of the compound is the entire component, the entire compound, okay? And the mass of the element is that part of the compound. In my example with pizza, that means the entire mass of the pizza, and the mass of 1/4 of that pizza. Okay? So, let's take a look at the sample problem on page 306. When a 13.6 gram sample of a compound containing only magnesium and oxygen is decomposed, 5.4 grams of oxygen is obtained. What is the percent composition of this compound? Okay, as always, we list what we know. The entire mass of the compound is 13.6 grams of the compound, okay? Magnesium oxide. The mass of the oxygen in that compound, So the mass of just the oxygen in that compound is 5.40 grams. The mass of the magnesium, of course, we can calculate. Mass of the magnesium we can calculate by simply subtracting 13.60 minus 0.540, and of course we're going to get 8.2 grams of magnesium. Okay? So, now it's time to calculate percentage. So what we need to do is take the mass of the oxygen and the mass of the magnesium. And we'll start with the magnesium just because that's how they do it in the book. So it's the magnesium is 8.20 grams of magnesium over 13.60 grams. That's the total. So this is that, and this is that. Multiply that by 100%. And when we do that, we get a approximate number of 60.3%. So 60.3% of the compound is made up of magnesium. Now, you can take a shortcut here, of course, and just subtract that from 100, and you know you're going to get 39.7, but that's not what you want to do. You want to calculate the mass of oxygen, because if you made a mistake up here, taking the shortcut will reveal that you got a wrong answer, and you don't want that. So, now we take the mass of oxygen, and that is 5.40. This is oxygen, 5.40 grams, divided by 13.60, multiplied by 100%, and we get 39.7%. And that is how you calculate percent composition from mass. Should equal 100, and it does. So now we're going to talk about calculating the percent composition from a formula. So if I give you a formula like H2O2 and ask you to calculate the mass, so what we're going to do is use the following conversion formula. The mass of the element in 1 mole divided by the molar mass of the compound multiplied by 100%. So let's take a look at 10.10 on page 307. Propane, C3H8, the fuel commonly used in gas grills, is one of the compounds obtained from petroleum. Calculate the percent composition of propane. Okay, to save time, I've listed the mass of carbon in 1 mole of C3H8 as 36. Now we got 36 because it was 12 times 3. Remember, carbon's mass is 12 times the 3 equals the 36. And then hydrogen's 1 times 8. This is that step we did in the previous video. Gives us a total of 44 grams. This is the bottom. So now what we need to do is take 36, calculate carbons, 36 grams divided by 44, and multiply that by 100%. And we take 8 grams and multiply that by 100%. And this will give us our formula, and that comes up to 81.8%, and then it comes to about 18% for hydrogen. Okay? So what we did here is, remember, this step right here was done by taking carbon's 12 and multiplying it by 3, and hydrogen's 1 and multiplying it by 8. And that came up with 36 and 8. Alright? So you have to calculate the mass of the compound before you can go on in this step. Alright? And that is all.